He has worked on over 350 major projects in Australia and across the USA. With an international team of over 50 engineers, he leads the development of power monitoring control systems for integrated energy management and DER orchestration, with extensive experience in traditional and renewable energy systems for utility, commercial and industrial markets. Please welcome James.
Thanks, Brett, and thanks to Quentin, and thanks for everybody that have actually been on this journey for 15 years. Azo's home is here, so it's nice to come to our headquarters here in Tonsley. I'm so inspired every time I come here. There's more and more innovative companies that have joined this amazing innovation precinct, and it's really nice to share the stage with Brett and others today. I'm going to be talking, following on from Brett, I'm going to be talking about battery storage and putting that into the context of the energy IoT landscape and showing you not just a long case study, but a few smaller case studies, some of which involve Tesla, some of which involve others, but all of which are very relevant to the clean energy future that we're all ushering into Australia and the whole world. My background is very technical, so if I get into some technical detail, that's something that unfortunately we have to be able to grapple with. When you consider all the technologies that are available, these things don't just happen, they're not just numbers on the page, they actually have to work. So my background in the technical side coming up through Azo for the last 15 years has exposed me to a lot of things that have led to what I'll be able to share with you today. So let me just take you through for the next 15 minutes or so we're going to go through. I'm going to set the stage for the energy IoT landscape generally and how we fit into it. And then I'm going to give some punchy case studies just to show one or two views into what we're doing with energy storage and technology around Australia, some of the projects of which are here in South Australia, and all of which should be inspiring to our transformational future. Now, I've done this myself. I'm happy to say I'm not part of a VPP yet, Brett, because I've got the power all at once, early adopter over here. But I have indeed, a lot of things that have been happening this week. I've actually, this is Future Energy Week, and the last couple of days, really looking at the things that people have been talking about. I'm trying it first. I'm driving an EV, using EV chargers, integrating battery technology, solar, and of course, everything else that we're trying to do. Some of us have been talking about what we can do with, even in the future, what we're going to do with things like appliances. I'm trying it, and I'm sure, and certainly I hope that everyone else is doing the same. I was at All Energy Week last week, and what I could say is technology anxiety is upon us. When you look at all of the technologies that are available, how does technology and battery storage work together? Well, they're essential for each other, but it's not always that easy to actually make them happen. And as some people have walked through All Energy, and I'm sure maybe some people feel that way today, the big question is how do we make all this technology come together to unlock the energy future? And we saw this theme of integrated, fully stacked integrated technologies versus individually integrated technologies. And I think as we've seen some examples of, the future is going to be the best in class of every kind of project integrated together rather than a uniform, homogeneous, single set of technology that any one company is going to be able to provide. I think it's great that we have some companies that are able to offer that, but the future of the whole energy economy is going to be integrations of lots of different technologies, and we've been able to do that with some other providers, a number of providers, and hopefully we can continue to see more and more of that technology happen. A model that often gets used is the energy IoT reference model, and that really outlines the technology that's required for this future to be transformed in three different areas. One, which is operational technology, including batteries, EV chargers, and edge DERs, as well as energy business systems, planning, DERM systems. But there's this middle kind of a system where we see an urgent need, which is to actually unify these excellent business systems, forecasting systems, along with the edge operational technology, and that's sometimes described as an energy services cloud. And that's actually what Azo has done here, right here from South Australia, exporting it to the rest of Australia and now out into the world. our mantra for this platform, and what we're trying to encourage people to adopt similar concepts for, is unlock your energy ecosystem. This is what we want to do. A lot of people feel locked into their technologies, and they have no way to integrate that technology with other emerging technologies. Our goal and our mission for this platform is to actually unlock your energy ecosystem. Now, if you look on the screen now, you'll see, think about was quote a movie earlier this year, The Multiverse of Madness. I don't know if people saw that. Well, sometimes we feel like the energy economy is this multiverse of madness. All this dimensionality between external data sets, modeling companies, feeds from AEO, orchestration platforms, and then traditional systems like BMSs and business intelligence systems. And all of those things are now connected in this great Internet of Things, and we need to bring all of that technology together to maximize the amount of value that we can extract from those technologies. So when we think about a virtual power plant, for example, that Brent just mentioned, the data flows and decision making for energy storage systems particularly are many and varied. There's local communications, there's cloud connected communications, there's systems that are there to be able to take what could happen in the future, what might happen in the future with past data sets and put those things together to try to make a decision of how best to dispatch this plant. And as we heard a couple sessions ago, that also includes EV chargers. I would like my car to be able to participate in a virtual power plant of the future as well. So that is the energy IoT landscape. So now let's talk about some examples of how energy storage systems and technology are coming together. It was amazing being at All Energy the last week and looking and hearing the stories from customers that are seeing unlocked value, both developers and clients seeing value that's been locked up, which is then unlocked by integrated technology. And I'll give you a few examples of that. First one that was on the pitch for today's session is Deakin University. Deakin University is the largest solar microgrid behind the meter, a university campus, an actual utility scale solar farm with a utility scale battery as part of the actual university campus. It's a 7.2 megawatt system with battery and solar, but not only is it helping the university actually cover basically half of its energy requirements, but it's also providing a lot of education and research opportunities. And in order for that to happen, have to work with a lot of companies that need to figure out how to bring these technologies together. We need to define expectations of the system, understand how the system is going to be operated, and in this particular case, release this development of this project in small work packages to be able to address the needs as these new technologies are emerging. And look how many different kinds of companies are involved. You have DNSPs, developers, electrical contractors, consulting engineers, and system integrators like ASO. All have to be together to make projects like this happen. And not only the companies, but the technology providers. In this particular battery storage system, all of these various technology providers had to be integrated together to be able to unlock the value of that energy ecosystem, whether that's trackers or inverter manufacturers, power quality metering providers, battery storage companies, and cloud analytics all coming together. So when you think about the challenges that are faced, you have things like, how do I move from an analog energy design to a digital energy design? How do I work with a system integrator and know how to plan and integrate these technologies together? How do I do this in a secure way? If that's not topical, I don't know what is. How do I do this in a secure way? And what do I do about ongoing maintenance, O&M, service for these technologies? These are all challenges, and the way that we've overcome these challenges was by, as the previous slide, all working together to unlock this energy ecosystem. And this allows the university then to have a single pane of glass to see the performance, the real-time operation of the place. We can see historical information, and also, as a design principle, have everything under one banner. Also, it allows them to design for security in mind. This is a structured, high-speed, secure network. To make this actually happen, you should just see Hornsdale. What's underneath the hood at Hornsdale? The amount of data that's required to dispatch this plant. Also, the university is able to do a digital twin. So not only a digital twin, a mimic of the actual site remotely, but actually make a data-driven digital twin to do both real-time control and simulation. And also having good control panels for commissioning, drilling down into the battery to allow the battery to operate in these various different modes, many of which have emerged out of the learnings from Hornsdale as an example. But some of these things are new ways to use this technology that haven't been done before. This is what's going to unlock the future. Another example using a Tesla Megapack. In this case, this is an example of a Megapack that is on market, that is one of the first ones that's co-optimized. It's participating in both energy markets and ancillary service markets together. This is the first of a kind as a partnership between a private developer who needed to unlock their energy ecosystem. One of the things that we believe that's important for technology and storage is no more black boxes. It's very difficult to innovate when you don't know what's going on under the hood. So we philosophically have made sure that you always have a good control panel, no black boxes. You should always know how this plant is behaving and why. And also that emphasis on security on the network and access control for users. It's very important for these technology rollouts to be able to have good performance tracking against the markets they're supposed to be unlocking. So we believe it's very important to be able to see energy markets, ancillary services markets, and even just asset dispatch in real time. And thanking Jonathan, one of our engineers in the back, for providing me this. It's very important to have good data, because if we don't have good data to turn it into information, we can't determine how we can actually operate these plants in a better way. One that's coming home to South Australia to a port pier near you, not that it's very close to here, but we're soon going to see hybrid plants like this one that's about to be built early next year. It's in the process right now. Gad will see these integrated vanadium flow batteries also be able to participate in unlocking the new economy and the new value streams that are coming. This will be a DC coupled, similar to the ones on my house, similar to ones that maybe some of you have seen in the past. This will be the first time where a large-scale vanadium flow battery is used to use various different value streams to unlock. And some examples of that are using these kinds of technologies for different patterns according to the availability and needs of the grid, stacking multiple cycles, some for arbitrage, some for solar shifting or solar soaking, and of course for ancillary markets like FCAS. There are lots of different value streams, all integrated, and these are things that a lot of these things are being firsts in South Australia. Speaking of firsts in South Australia, power packs. I know they're not making them anymore, but South Australia Produce Market out north was one of the first projects to be a microgrid behind the meter using power packs to be exposed to the spot market and automatically buy and sell on the market to provide benefits both to the tenants to help them reduce their energy costs, as well as support the value streams that the produce market needs to make sure that the rolling out of these things is economical. And one of the things that is challenging in this regard is load coupling. So a battery energy storage system with FCAS, this is very important because it's actually not that easy to bid what you could actually achieve with these projects when you're coupled with a variable load. And we're very excited that technology has been increasing rapidly to be able to offer the analytics that can help us actually do that. And then the last one is Ampol. Hopefully some of you have seen this week. We're really excited. Tying into the previous session, Ampol finally providing to the masses lightweight commercial residential vehicles that allow us to do high-speed charging systems around the country. There's hundreds of these being rolled out now, and we're very excited to have been part of these. But this is sort of just an example. These are mini microgrids that are being used to create the service station of the future, overcoming the limitations of physical infrastructure, overcoming the limitations of the battery technologies themselves, all integrated together in a mini microgrid, doing things like load management, peak demand management, and similar to the others, multiple value streams while the EV charging is idle. So I'm going to leave you with this. How do we drive the total cost of energy, or the total cost of ownership down? We believe it's integrated technology, so we don't get stuck and not being allowed to unlock the value that's there. We want to be able to drive the total cost of ownership down, and we believe that integrated technology is the path to a sustainable world, and this is a way that we can do that. So we need to do three things. One, Pick 2, let's not force our project developers to do good, fast, and cheap. Pick 2, and we'll be able to develop more and more of these projects. Second, let's make sure these projects are future-proofed so that the power of and, we can do ancillary markets and support grid stability and support infrastructure. We want to make sure that these projects are designed to be future-proofed. And lastly, let's make sure that these designs that we're adopting are reconfigurable assets that help us to unlock people's energy ecosystem during the whole life cycle of the asset.